students, I hope all of you are doing good. Let's start today's chapter, integer. After reading this chapter, you will be able to know about all these given topics. Okay, so let's get started. Introduction. In our earlier classes, we have learned about numbers such as natural numbers and whole numbers. Numbers starting with 1, 2, 3, 4, etc. are called natural numbers, which you already know. And numbers which start with 0, that is 0, 1, 2, 3, 4 are called whole numbers. The numbers 0, 1, 2, 3, 4 together with negative numbers, that is -1, -2 and -3, etc. are called integers. 1, 2, 3, 4 are known as positive integers and -1, -2, -3 are known as negative integers. Okay, so whenever there is a negative sign before a number, then that number is negative integer. Okay, and if there is no sign, that means it is positive, right? Special role of integer 0. 0 is neither considered positive nor a negative integer. P. Non-negative integers, that is those integers which are not negative, are 0, 1, 2, 3. Here 0 is included, but positive integers start from 1, 2, 3. Here 0 is here excluded. See, non-positive integers, that is those integers which are not positive, are -4, -3, -2, -1, 0. Here 0 is included, but instead of negative integers, -4, -3, -2 and -1, here 0 is excluded. D. So 0 is neither even nor odd, but while grouping 0 is accepted in group of even integers, right? Remember, major mistake territory of integers. When we look two signs, numbers, that is negative and positive, sometimes we get confused about which number is larger. Remember, A. 0 is always less than positive integer. Remember that. If we have to compare 0 and 5, then 0 is obviously lesser than this positive number. B. 0 is always greater than negative number. If we are comparing 0 with a negative integer, then to remember 0 will always be greater than negative integer, right? C. Positive integers are always greater than negative integer. Okay, and D, when we compare two negative integers, the integer which appears greater is actually smaller. Okay, got it? See, we are comparing two negative integers. Here we see that 10 is greater than 2, but there both these numbers are negative integers. So whenever you find two negative integers and you have to compare them, then always remember the number which appears greater is actually what? Is actually smaller. Okay, we can represent integers on the number line such as we represent numbers, negative numbers and positive numbers on number line, right? There is no smallest or largest integer in world of mathematics. Okay, and number 2, if two negative integers are plotted on number line, the negative integer closer to 0 is always greater than the further negative integer. Okay, now addition of integer. We have already learnt that number 1, sum of two positive integers is always positive. Okay, and the sum of two negative integers is always negative integer. Remember that. Okay, case 1, addition of integers when their signs are same. The rule is add the numbers and give the common sign. Okay, suppose we are adding same signs, means +5 +4. Okay, we have to add them up. So what is the answer? 9, and you will give it a sign of plus because we have to put here the common sign. And if we are adding -5 and -4, then what will happen? Again, you will add them up because both the sign are equal. You will get 9, but this time -9. Okay, let's do example 1. Number 1, 415 and 525. You have to add these two numbers. This is very simple. 940 you will get, and both the numbers are of positive signs, the sum will always have positive sign. Second case is -79 and you have to add -27. Okay, so first you will add these two numbers, so you will get what? 106. Okay, 106 is the sum, but what about the sign? Since both the numbers have negative sign. So therefore, sign here will be negative. Okay, got it? Case 2. When integers are of unlike sign, means the signs are not the same. So the rule is subtract and give the sign of bigger number. So in this case, you're gonna do is subtract the numbers. For example, add minus 75 and 50. Okay, now we have both different signs. Now what will we do? We will subtract. So what will you get after subtracting? 60. Now what about the sign? Sign, you will get negative. Okay, so here in this example, here 45 is written, but I have written here a 15. Okay, next, add minus 25 and 90. Minus 25 plus 90. Again, signs are unlike, so you will subtract. And now what will be the sign before 65? We will not write here negative, we will write positive, because according to this rule, give the sign of bigger number. So which one is the bigger number? 90. So we will give the sign of that number only. Okay, next, subtraction of integers. Subtraction is the opposite of addition. We already know that. The rule to subtract a from b is to add negative of a to b. So if you have to subtract two numbers, okay, see, you have to subtract a from b. Okay, so what will you add? What will you do? B plus minus a. Okay, is to add negative of a to b. Okay, so what will you get? B minus a is equals to b plus a. Okay, so let's do the example. Subtract 4 from 10. Okay, so 10 minus 4 is equals to what? 10 plus minus 4. So 10, then you will do minus, answer is 6. Similarly, you have to subtract minus 7 from 15. Okay, now this time you will subtract minus 7 from 15. Okay, now what will you do? 15. Okay, see, remember this rule, 15 plus and plus 7. Okay, and 15 plus 7 is 22. So 22 is the answer. Okay, so in the same way you will do example 3 and 4. No more. A. In subtraction, we add the additive inverse of integer that is being subtracted to the first integer. B. After changing subtraction into addition, we can use all applicable rules of addition, right? Absolute value of an integer. The absolute value of an integer is its numerical value regardless of its sign. For example, minus 20. Absolute value of minus 20 is 20. Absolute value of 15 is what? 15 only. Okay. Minus 45 is equals to 45. Means the absolute value of minus 45 is 45. Okay. Let's check out common mistakes. Don't use the word minus for the negative numbers. Example, minus 15. Okay. So read it as negative 15. Never call it minus 15 because minus word gives the signal of subtraction to our brain and we may go wrong. Okay. Example 4, write the value of, okay, so 18 minus 26. So first you will minus 26 from 18. So what will you get? You will get a minus 8. And what will be the absolute value? Absolute value will be the number itself. Okay. Okay, so similarly you will do other parts also, right? Let's do exercise 1.1. Answer the following. Number 1. If 20 meter towards east represents positive 25 meter, then what will 25 meter towards the west represent? Obviously, what will it represent? Negative 25 meter. Okay. Second part, if 8.5 kilometer uphill represents positive 8.5 kilometer, then what will minus 8.5 kilometer represent? So, opposite of uphill is downhill. Okay, so you will write here downhill. Right, students? Properties of integers. Properties of addition of integers. Number 1. The sum of two integers is also an integer. For example, minus 5 plus 4 is equals to minus 1, which is also an integer. Okay, this property is called closure property of addition of integers. You can try a few more examples like minus 15 plus 7, 13 plus minus 8, 11 plus 8, or minus 15 plus minus 2, etc. by number line method and confirm they all are obeying closure property. Okay. Property number 2, the sum of two integers remain unchanged if they change their places. For example, minus 3 plus minus 2 is equals to 5. If you change their places, like minus 2 plus minus 3, answer will be same, minus 5. Here also there's minus 5. Okay, right students? So this is what? This is called commutative law of addition of integers. Okay, remember that. Okay, try by the integer number line method the result for these given examples. Okay, and confirm whether they obey commutative law of addition or not. Now property 3. For any 3 or more integers, it doesn't matter in which order they are being added. The sum always remains the same. For example, minus 2 plus 5 in bracket, minus 2 plus 5 in bracket plus 3 is equals to what? 3 plus 3, 6. Okay. Also, minus 2 will take it outside the bracket, and in bracket we'll add 5 and 3. So what will get the answer? Minus 2 plus 8 is equals to 6. So it doesn't matter in which order we add numbers, okay, so because the sum always remains the same, right? Next property. What do we call this property? We call this property as associative law of addition of integers. Okay, and now try and verify the result for the following examples which are given here. Okay, now property number 4. If a 0 is added to any integer or integer added to 0, the sum equals the number itself. For example, 8 plus 0 is what? 8, or 0 plus 8 is what? 8. Okay. Here 0 is called additive identity of integers. Okay, and try and verify the result for this also, and you can take few more examples of same type to confirm the result. Okay, number 5 property. For every integer there exists an integer such that their sum is 0. For example, minus 8 plus 8 is equals to 0, or 8 plus minus 8 is equals to 0. Okay, minus 8 plus 8 is equals to 8 plus minus 8 is equals to what? 0. Okay, so such integers are called additive inverse of each other. Okay, means additive inverse of 8 is what? Minus 8, and additive inverse of minus 8 is what? Positive 8. Okay, so minus 8 is additive inverse of plus 8, and plus 8 is additive inverse of minus 8. Okay, so try and verify the result for minus 4 plus 4 is equals to 4 plus minus 4 is equals to 0. You can try a few more examples of same type to confirm the results. Okay, now properties of addition and subtraction of integers. Addition. Closure property. The sum of two integers is also an integer. That is, integers are closed under addition. If x and y are integers, then x plus y is also an integer. For example, 3 plus 4 is equals to 7. 3 plus minus 4 is equals to minus 1. Okay, so whenever you add two integers, the sum is also an integer. Okay, so this is the closure property of addition. And now, what does the closure property of subtraction say? The difference of two integers is also an integer. That is, integers are closed under subtraction. If x and y are integers, x minus y is an integer. For example, minus 5 minus 3 is equals to minus 8. And 6 minus 4 is equals to what? 2. So whenever you subtract two numbers, two integers, the difference is also an integer. So this is what closure property of subtraction says. Okay. Commutative property of addition. The sum of two integers remains unchanged if they interchange their places. That is, x plus y is equals to y plus x. X and y are integers, okay, which we already studied. Like, for example, 5 plus 3 is equals to 8. 3 plus 5 is equals to 8. Okay, so addition of integers is commutative. Okay, now let's check out what does the commutative property of subtraction say. The difference of two integers doesn't remain the same if they interchange their places. That is, x minus y is not equal to y minus x. Here x and y are integers. Example, 5 minus 3 is what? 2. But minus, if you subtract 5 from 3, 3 minus 5 is not 2, it's negative 2. Okay, so subtraction of integer is not commutative, right? Next, associative property of addition. For any 3 or more integers, it doesn't matter which 2 are added first and then the sum is added to the third integer. Like x, y, z be integers. So x plus y plus z is equals to x plus, then in bracket y plus z. For example is given here. Okay, the answer doesn't change. So addition of integer is what? Associative. Next, associative property of subtraction. For any 3 or more integers, it matters which 2 are subtracted first and then third is subtracted from their integers. Let x, y, z be integer. So x minus y minus z is not equal to x minus y minus z. For example, see, 5 minus 3 in bracket, then minus 2 is equals to 0. But 5 minus, then in bracket 3 minus 2 is 4. So subtraction of integers is not associative. Okay. Next, additive identity. If a 0 is added to any integer, the sum equals the integer itself. For x, if x is an integer, then x plus 0 is equals to 0 plus x is equals to x. For example, 6 plus 0 is 6. 0 plus 6 is what? 6. So 0 is what? Is additive and additive identity. Okay, remember a major mistake territory. 0 is not a subtractive identity because 6 minus 0 is equals to 6, but 0 minus 6 is not 6. 0 minus 6 is what? Minus 6. Okay. Next, additive inverse. For every integer, there exists an integer such that their sum is 0. Each of such numbers is known as the additive inverse of the other. For each integer x, there exists an integer minus x such that minus x plus x is equals to 0. Both x and minus x are additive inverse of each other. For example, plus 4 plus minus 4 is equals to minus 4 plus 4 is equals to 0. Okay, no more. Additive inverse of positive integer is negative and vice versa. Number 2, additive inverse of 0 is 0 itself. Okay. Next, properties of subtraction of integers. Difference of 2 integers is always an integer. For example, 5 minus, and then in bracket minus 2 is equals to 5 plus 2 is equals to 7, and minus 3 minus 4 is equals to what? 1. Okay. That is, subtraction of integers follows a closure property. Remember that subtraction of integer is neither commutative nor associative. Okay. Remember that. Now, multiplication of integers. Consider only positive and negative integers. We may have 4 types of products, which are positive integer into positive integer. Okay, the answer is positive integer. Positive integer into negative integer, then the answer will be negative integer. Then negative integer into negative integer, the answer will be positive. And negative integer into positive integer, the answer is negative. Okay, let's do example 5. Multiply minus 4 and 8. 14. Okay, minus 14 into 8. So, which rule is this? This one. Negative integer into positive integer is equals to negative. So, whatever answer you get, you will always put a negative here. Okay. In part 2, 18 into 3, both are positive integers, so answer will be positive integer. Okay. And number 3, minus 25 into minus 3 is 75. Okay. Here again, both the signs are equal. So, whenever there are equal signs, the product will always positive. Okay. Remember, major mistake territory. It is wrong to read product of minus and minus is plus. Sometimes we really add the numbers instead of multiply. Read as product of 2 negative integers is positive number. Then we will always multiply, we will never add them. And solution tips. Don't see the sign of numbers, just multiply 2 absolute values. And always remember, product of 2 integers with same sign is always positive. Okay, so whenever you find 2 same sign, the product will always be positive. And number 2, product of two integers with opposite sign is always negative. Okay, now real life situations where product of integers is involved. Here are some examples from day-to-day life situations where multiplication of integers is involved. Number 1, the temperature of a place changes 2 degrees Celsius each hour for 6 hours. The total change in the temperature in 6 hours is given by 2 degrees Celsius into 6 is equals to 12 degrees Celsius, right? Number 2, if a person loses 100 rupees every day in a game, then the money that he will lose in 10 days will be given by minus 100 into, why minus? Because he is losing that money, okay? So, negative 1000 rupees is the answer. Your negative sign stands for loss. Number 3, if there is an increase of rupees 500 in a person's salary every year, then increase in his salary after 8 years will be, you will multiply 500 by 8. So, you will get rupees 4000. Okay, students. Now, let's do exercise 1.2. Fill in the blanks. Minus 70, okay, let's change the pen. Minus 70 plus dash is equals to 40 plus minus 70. So, what will you write here? See, minus 70 is there, minus 40. You will write here minus positive 40. Okay. 0 plus 80 is equals to 80 plus 0 only, right? Now, properties of multiplication of integers. Property 1. Closure property. The product of two integers is also an integer. If a and b are two integers, then a into b is always integer. Okay. See. Number 1 statement is minus 10 into minus 11 is equals to 110. Observation, it is an integer. So, closure property is confirmed. Okay. Property 2, commutative law. The product of two integers remains same if they interchange their places. If a, b are two integers, then a into b is equals to b into a, which you already know. Okay. So, 4 into minus 3 is equals to minus 12 and minus 3 into 4 is equals to minus 12. Okay. So, there is no changes in the product. That means commutative law is confirmed. Okay. Same in these examples, you can check the product remains the same. Number 3 is associative law. Property number 3. The product of 3 or more integers remains the same irrespective of the order in which they are multiplied. If a, b, c are 3 integers, then a into b into c is equals to a into b into c. Okay. So, statement 1 is 3 into, that in bracket 2 into minus 5. Okay. So, the answer is minus 30 and statement 2 is 3 into 2. Now, 3 into 2 is in bracket and then minus 5 and the answer is 30. That means associative law is verified. Okay. So, no matter if you change the order of the integers, the product always remains the same, right? Maths extension. Associative properties, change of brackets or change of grouping only. It makes multiplication very easy. As an example 3, that is property 3. Calculation of statement 2 is easier than statement 1. Okay. Number 4 property, multiplicative and identity. If any integer is multiplied with 1, the product is always the same integer. If a is an integer, then a into 1 is equals to 1 into a is equals to a. For example, 9 into 1 is equals to 9. Minus 8 into 1 is equals to minus 8. So, here 1 is called multiplicative what? Identity. Okay. Remember, for all integers, additive identity is 0 and multiplicative identity is 1. Don't mix up with when we learn both identities. Sometimes we do this mistake. So, always remember that. Okay. Additive identity is 0 but multiplicative identity is 1. Okay. Now, let's move on to next property. Property number 5, multiplicative property of 0. Product of any integer with 0 is always 0. For example, 5 into 0 is 0. 0 into 5 is 0. 215 into 0 is 0. No matter how big the number is, if we are multiplying this integer by 0, the answer always remains the 0. Okay. Number 6, multiplicative property of minus 1. Product of any integer with integer minus 1, we get its additive inverse. If a is an integer, then a into minus 1 is equals to minus 1 into a is equals to minus a is additive. So minus a is additive inverse of a. For example, 7 into minus 1 is equals to minus 1 into 7 is equals to minus 7. Here 7 is additive inverse of 7. Okay. And in this question, example, minus 8 into minus 1 is equals to 1, minus 1 into minus 8 is equals to 8. So here 8 is additive inverse of minus 8. Okay. Number 7, distribution of multiplication over addition of integers. For any three integers, the product of first integers and the sum of other two is equals to the sum of the product of first and second and first and third integers. If a, b, c are three integers, then a into then b plus c in bracket is equals to a into b plus a into c. Okay. So statement 1 is what? See, what does this statement say? 4 into 10 plus minus 3. Okay. So it will become 4 into 7, that is 28. Okay. This is statement 1. Now statement 2, what does it say? It says 4 into 10 plus 4 into minus 3. So 40 minus 12 is equals to 28. The product is same. Okay. So distributive property of multiplication over addition is verified. Okay. You can also check in these examples also. Maths extension. Distributive property of multiplication is applicable for subtraction also. That is a into then b minus c in bracket is equals to a into b minus a into c as shown in examples 3 and 4 property. Okay. Example 3, calculate and verify using commutative law. Okay, you have to multiply and then you have to verify. So see, 14 into minus 3 is equals to 13 minus 14. 14 into minus 3 is what? If you will multiply, you will get minus 182. And if you multiply minus 13 by 14, again you will get minus 182. So LHS is equals to RHS. Okay, so verified. Right? No more. Distributive property is helping to make the solution very easy. It can be used both ways. Number 1, a into then in bracket b plus c is equals to a into b plus a into c. See, minus 45 into minus 98 is difficult. By using this property, we can make it easier. How? See, we can write 98 as minus 100 plus 2. Okay. Now, what will you do? You will multiply minus 45 by minus 100, then plus minus 45 into minus 2. Now, this has become easier to solve. You will get here 4500. See, both signs are equal, so we will get the product as positive. We will get 90. Now, 4500 minus 90 is equals to what? 4410. Right? Number 2 is a into b plus a into c is equals to a into b plus c. Okay. So this, as you can see, this calculation is a little bit difficult. So by using this property, we can make it easier. Okay. So the benefit of the properties is that we can make any difficult question and we can change it into the easier one. Okay. So observe the question, use this property if possible to simplify the task, frame few more questions of this type and use the distributive property to make the solution very easy. Okay. Example 7, calculate and verify the associative property. Okay. So here it is given. You have to multiply 3 numbers. Here it is given 5 into, so first I am taking LHS, that is left hand side, 5 into 3 into minus 2. Okay. So I am taking here what? LHS. Then what will you do? 5 into 3 and then minus 2. 5 into 3 is 15. Minus 2. So you will get answer minus 30. Okay. So this is LHS. Now I will take RHS is 5 into 3 into minus 2. Okay. So same step we have got here, right? So this is also what? Minus 30. So LHS is equals to RHS. hence it is verified. Okay, let's check out what the common mistakes. Read the question carefully, especially the questions in which multiple operations like multiplication, addition, subtraction are done together. Okay, example number 8, you will here use distributive property of multiplication over addition for integers to calculate the answer, right? And remember, take care of negative sign in question of multiple operation. See carefully that it is a negative number or it is asked to subtract. Okay, now product of 2 or more negative integers. Number 1, product of 2 negative integers is positive, which you already know that, because whenever you will multiply 2 negative integers, the sign is similar. Okay, so the product will be positive. Okay, so -4 into -6 is 24, or -1 into -2 is equals to 2, right? Number 2, product of 3 negative integers is negative. Okay, this you have to remember, product of 3 negative integers is negative. For example, here -8 into -5 into -2 is equals to -80. Okay, because here we have 3 negative signs, so the product will be negative. Number 3, you can check with some example like you have given here -2 into -3 into -5 into -7, and then -3 into -4 into -5 into -8 into -9. That product of 4 negative integers is positive and product of 5 negative integers is negative. In short, what you have to do is you will have to count the number of negative integers or number of negative signs. Okay, if the negative signs in odd numbers, then the product will be negative, and if the number of signs of minus is even number, then the product will be positive, right? This is a trick, a short trick, no more. -1 into -1 is equals to +1. Then here 1 is multiplied 3 times, the answer is -1. Here -1 is multiplied by 4 times, so answer is +1, and so on. So 2, in product of few integers, if number of negative integers is odd, then final result will be negative integer. Number 3, in product of a few integers, if number of negative integer is even, then final result will be positive integer. Okay, which I just told you. And number 4, in product of few integers, if one integer is 0, then final result is 0. Example, multiply all the integer from -10 to +10. Okay, since 0 is one of the integers, but out of 21 integers, final result will be 0. Okay, let's do exercise 1.3. Which of the following statements are true and which are false? Calculate 6 into -3 is equals to -3 into 6. -18 is equals to -18. So the answer is true. Okay, if you don't get both sides equal, that is LHS is not equals to RHS, then you what will you write? False. Okay, see, take one more example. -5 into 4 into 6 is equals to -5 into 4 into 6. 20 minus 26 minus 5 into 24. So you will get here -120. Here also you will get -120. So both the sides are equal. This is also true, right? Maths extension: to read, to plan, to do, to check. Read the problem carefully, and if you can't find strategy, make a list, guess or draw picture or find pattern. If you don't mind, by choosing the operation, computing and estimating whether it needs 1 step or maybe 2, this will make word problem painless for you. The time has come to do the plan and see an answer with proper unit. There will be. Okay, so remember, word problems involving integers should be read carefully. State, if not given in question, that which is taken positive or negative. Number 1, rise of temperature, saving, profit, upward heights, marks obtained in examination, etc. are taken positive. Number 2, fall of temperature, expenditure, loss, downward distance, depth, marks lost in examination are taken positive. Okay, remember them. Let's check out word problems involving integers. Example, a submarine is at a depth of 200 meters. So your depth is taken negative. Okay. So if the ocean bed is 960 meters from the surface, how far is the submarine from the ocean bed? Okay. So from solution, what does the solution say? From the surface of the sea, if we consider distance below the surface as negative. So depth of submarine is what? Minus 200 meters, right? And depth of seabed. This is depth of submarine. Okay, and depth of seabed is what? Minus 960 meter, and what you have to find out is how far is the submarine from the ocean bed. So how you gonna find distance? You will subtract this one from this one. So minus 200 meter minus 960 meter. Okay, if you remember this property, we will write here 960 meter. Okay, now you will get the answer, which is 760 meter. Okay, and one more line is written over here, that remember that distance is always a positive number, right? Let's do exercise 1.4. A person gained rupees 500 every day for 15 days in a game. He lost rupees 250 every day for next 8 days. What is his final gain or loss? First, we will find out his gain. Okay. So he gained in a day. How much he gained? Rupees 500. So he gained in 15 days. Gain, so positive, this is positive. Okay, so rupees 500 into 15, so his gain is 7,500 rupees. Total he gained that much. But next he lost 250 rupees for next 8 days. Okay, so he lost in a day rupees 250 minus, because he is losing money. Okay, so he lost in 8 days. You will multiply minus 250 by 8. So what will you get? 8 5s are 40, 4 carry, minus 2,000 rupees he lost. And we have to find out what is his final gain or loss. See, he made a profit of 7,500 rupees and he made a loss of rupees 2,000. So obviously his profit is more than the loss. So he made a profit, and profit of how much? What will you do? You will subtract, because this is the loss. Okay, so what will you get? You will get 5,500 rupees. So he made a profit of rupees 5,500 rupees, right? Now division of integers. Division is inverse operation of multiplication. See, 5 into 5 is equals to 25, and if we divide 25 by 5, we get the 5. 24 is equals to 3 into 8. Okay, and 24 divided by 3 is equals to 8, and if you divide 24 by 8, you will get 3. So we see that for one multiplicative statement, there are always two division statements, right? See, 12 divided by 6 is equals to 2, minus 12 divided by 6 is equals to minus 2, and 12 divided by minus 6 is also minus 2, and minus 12 divided by minus 6 is equals to 2, right? No more. Thus, when a positive integer is divided by a positive integer, quotient is positive. Also, when a negative integer is divided by a negative integer, then too quotient is positive. B. When a negative integer is divided by a positive integer, or a positive integer is divided by a negative integer, the quotient is negative in both the conditions. Okay. Maths extension. In general, if A and B are any two integers, then A divided by B is equals to minus A divided by minus B. Okay. And B is not equals to 0. and minus a divided by b is equals to a divided by minus b, but here also b is not equal to 0. Example, you have to divide minus 80 by 16. So when you will divide minus 80 by 16, you will get 5. When you divide 80 by 16, you will get 5, and after that you will put a negative sign before 5. Okay. Then in this question also you will divide, and then the answer or the quotient you get, it will be in negative. Okay. No more. The division of integer is not closed. Also, the division of integers is neither commutative nor associative. It doesn't obey distributive property also. Next, properties of division of integers. Let us see the following division. 16 divided by 2 is equals to 8, which is an integer, and minus 9 divided by 3 is equals to minus 3, which is also an integer. But minus 11 divided by 5 is equals to minus 11 by 5. The result is not an integer. Also, 7 divided by minus 5. What will we get? 7 divided by minus 5. It is also not an integer. Okay. So, let's check out the statement 1. 16 divided by 4 is 4. It is integer. But 4 divided by 16, see, if you divide 4 by 16, what will you get? You will get 1 by 4, a fraction. Okay. So, this is not an integer. So, inference is 16 divided 4 is not equals to 4 divided by 16. So, conclusion, what is the conclusion? Non-commutative, and statement 2 is a non-closure. Okay. Number 2, 24 divided by 12 divided 3. See, let's do this. Now, you have 3 integers. 24 divided by 12 divided by 3. Okay, so 24 divided by, when you will divide 12 by 3, you will get a 4, and the answer is here 6. It is an integer, right? Now, 24 divided by 12 divided by 3. First you will divide it, you will get 2 divided by 3. 2 by 3, this is not an integer. Okay, so what is the conclusion? Non-associative, and statement second is non-closure. Okay. Next statement is 15. Minus 15 divided by 3 is equals to minus 5. It is an integer. 3 divided by minus 15, that is 3 divided by minus 15 is equals to 1 by 5 minus. It is not an integer. So, what is the conclusion? Non-commutative, and statement 2 is non-closure. Okay. Number 4, 32 minus 32 divided by minus 4 divided by 2. Minus 32, and here you will get minus 2, and the answer is 16. So, 16 is an integer. Okay. But on the other hand, minus 32 divided by minus 4. Okay, and then divided by 2. So, here what will you get? First 8 divided by 2. Answer is 4. It is an integer. But conclusion is what? Non-associative statement. 1 and 2 both show closure property, but not always. Okay, it will not always show the closure property. Number 5 is 18 divided by 9 plus minus 6. Okay, now move on to next statement. Okay, see, minus 18 divided by 9 plus minus 6. So, minus 18 divided by, here what will you get? A 3. So, you will get a minus 6. And statement 2 is minus 18 divided by 9 plus minus 18 divided by minus 6. So, what here will you get? Minus 2, 3. So, answer is 1. Okay. So, what does the conclusion say? Non-distributive. Okay, divisor is not a distributive over addition or subtraction. Here 1 and 2 are obeying closure property, but remember, not always. Okay, always remember that. Division by 0. It is meaningless for all numbers, including integers. Example, minus 7 by 0, 15 by 0, minus 8 by 0, 7. It is meaningless. All are undefined because you cannot divide any number by 0. B. Division of 0 by any other integer. 0 divided by any non-zero integer other than 0 is always 0. Okay. C. Division of any integer by 1. When any integer is divided by 1, we get the same integer as answer. Example. C. If you are dividing 14 by 1, you will get 14. If you are dividing 20 by 1, you will get 20. Okay. In general, for any integer a divided by 1 is equals to a. Okay. D. Division of any integer by minus 1. When any integer is divided by minus 1, we get the negative of given integer, that is additive inverse. See, 4 divided by minus 1 is equals to 4, and minus 7 divided by minus 1 is equals to 7. Okay, so in general, for any integer a divided by minus 1 is equals to minus a, right? Let's check out example 12. The temperature of room is 37 degree at 12 noon. A machine started cooling the room at uniform rate. After 14 hours, the temperature of room will reach to minus 5 degrees Celsius. What is the rate of cooling? So first we have to find out total temperature to be lowered down. Okay, so how will we get this, the total temperature to be lowered down? We will subtract the initial temperature from the final temperature. Okay, so you will write here total temperature to be lowered down is equals to what? Final temperature. You know the final temperature? Final temperature minus initial temperature. Okay. See, initial temperature is 37 and minus 5 degrees Celsius is a final temperature. So, minus 5 degrees Celsius minus 37 degrees Celsius. See, both signs are equal. So, in this case, we're gonna add them up, but the sign will be negative only. So, 37 plus 5 is 42 degrees Celsius. Okay. Now, one thing also, negative sign indicates that is temperature is falling. Okay, it falls of temperature. Now, in 14 hours, fall of temperature is what? Minus 42 degrees Celsius. 14 hours are given here. So, you have to find out what is the rate of cooling. So, rate of cooling is what? Rate of cooling. You will divide this temperature by what? By how much? 14. Okay. So, 42 divided by 14 is 3, minus 3. So, minus 3 degrees Celsius. That is, the rate of cooling is equals to 3 degrees Celsius per hour, right? Let's do exercise 1.5. Evaluate the following. Minus 25 divided by 5 is what? 5, and then you will put a negative sign here. Okay. 81 divided by minus 3 is what? You will get a 27, but minus, you will put a negative sign here. Right, students? Now you will do the practice of the remaining questions and exercises.